the largest ONDC Rails infrastructure company in India right now, and we have actually we are doing a lot of AI. With the ethos of ONDC that you want to share a lot of whatever knowledge that you have with the community around. So we do these kind of webinars. In AI, basically, this is the first in the series. We'll do a lot of webinars around AI and go deep into AI. If you really want to understand AI with very basics of AI to in depth of AI, would recommend you follow these webinars as they happen during this year. Primarily, basically, the topic of today's webinar is LLM, and you might or might not have heard of LLM, but it's okay if you have not heard, or if you have heard. We'd love to take your inputs if you're an expert out there on what an LLM is. So we want this to be a participatory webinar. So feel free to ask any questions, if any comments, if you have any feedback, any input, feel free to share. Primarily, if you look at Plotch.ai, as I said, we are the largest in DC, and we are doing millions of transactions right now. We're the largest technology company. ONDC, we have talked about it in various webinars. You should look at, if you're not familiar with ONDC, what it is, because it's an interesting thing which is happening right here in India. Now, we are on a mission to transform commerce in India in ONDC network, and we are taking, a lot of AI and building a lot of AI into our, technology stack. And that basically, those learnings is something that we want to share so that, if you are looking to build something, adopt something in AI, if you are doing some fundamental research in AI, maybe, whatever we are doing can help you in furthering that. Now, basically, I'll start with this very simple slide. Attention is all you need. I don't know if any one of you here can understand what this actually means. Anyone here who can relate to what I'm mentioning here? If you have heard about AI before, if you're doing any research in AI, probably you have heard of this. So basically, I'll start with that. 8 Google employees, basically, they invented the modern AI. And in 2017, they published a very fundamental paper, which became the basis of the the AI that we are seeing today, generative AI that we are seeing today. And that basically the title of that paper was "Attention is all you need," right? And anyone who basically is doing any deep research in AI would know this paper very well. It was a landmark research paper, as I said, in 2017, written by, the Google employees, which are 8 of those. And what they defined in that was the transformer model, AI model, and GPT, which is basically a generative pre-trained transformer model. So the T part, the transformer part actually came in GPT. The T part came from that paper, and it just transformed how the generative AI after that, the way we do, the way it has scaled up and stuff, right? So it's important that that background is given to you, and attention is all you need is the paper. If you're doing any fundamental research, maybe that's the first paper you may want to read about AI. But surprisingly, 6 of the 8 authors actually were not born outside of United States, and that tells the diversity of folks who are involved in building AI across the world. And 8 of those authors have left Google and founded their own AI startup site. So that paper was so fundamental in transforming AI that all of them actually had started the AI startups and left Google, right? So it's a interesting fact I thought I'll share. Now, fundamentally, if you look at AI, basically is artificial intelligence, right? Just artificial intelligence. But artificial intelligence is a very wide topic. In that, basically, there's a subset called machine learning. basically tells that how can we how can we basically train machines to do things like a brain does, right? Kind of stuff, right? So machine learning is a very important field in artificial intelligence. In that, basically, there's a subset called generative AI, and that basically is what generative AI uses LLM, which is a large language model, and that's fundamentally the model which basically today a lot of generative AI tools use, which is LLM model. And in that LLM, one of uh, the key or the biggest LLM you can think of is the GPT, which you might have heard of, which is generative pre-trained transformer, right? It's important to understand this stack because a lot of times people confuse LLM with what's LLM, what's GPT, what generative AI, machine learning, and artificial intelligence. But it is basically that kind of drill down. It's important for you to understand that artificial intelligence has a machine learning subset, and that basically there's a subset called generative AI, and that basically the technology, the model which is being used is LLM, and one of the LLMs is GPT. And there are a lot of other LLMs, around in the world, and we'll get into that as we go further. So generative AI, there is AI and there's generative AI, right? Generative is a very important word here, right? Basically, it says generation of what? That can generate content of all format, which means text, audio, image, video, and a lot more, right? So fundamentally, if you look at generative, the word, if you look at generative, it means generation of content. And therefore, a lot of these LLMs, the chat GPTs and the applications which are built on these LLMs like chat GPT, Gemini, or even like OpenAI, Copilot from Microsoft, right? All these are generative AI, apps which are using these LLM models to create, generate text, which may be a question answer format, like when did, for example, when was Gandhiji born, right? It's fundamentally a factual question that you may want to get an answer from generative AI, or you may just ask, can you write an essay on, how should I improve my, diet, for example, something like that. Or you can ask to create an image, like how will India will be in 2015? Can you paint an image of that, right? Something like that, right? So you can do a lot of this stuff with these, with these apps, and they are part of, what they're doing is generative AI. So what can LLMs do, right? Before getting deeper into what LLMs are, what can LLM do? I mean, and it's important to understand what LLM can do. In the generative part itself, right? They can translate. They can actually translate from French to English, or they can translate from even in Indian languages. They can be translated, right? So LLMs have a capability to translate text from one language to another. They can answer, they can do a question answer kind of stuff, right? You ask a question, they can give you an answer. They can power chatbots. So you can actually have conversations, which is a contextual conversation with the, so chatbots can be based on LLMs, right? You can summarize, let's say if you give a very big article, or if you give a very big blog or news article, you know these LLMs can summarize that in like few sentences, right? So since it's an interesting application out of LLM, they can write code. So you can ask LLM to write a code about a Python code, a PHP code, a Java code, and they will be able to do that. They can do a sentiment analysis. So if you give a text, that's a review. It's an important review, like someone gives a review of a product. If you say, does this review have a positive sentiment or a negative sentiment? So you can trigger your internal customer care or internal workflows based on those sentiments. They can actually do product recommendations. So you can build product recommendations, power your search queries with LLM. And of course, LLM can generate images and future maybe videos also. So it's basically a lot of things LLMs can do. This is like some of the top things which people talk about LLMs. Interesting thing about LLM, and we will get into these LLMs. Is that they actually a predictor. They're basically predicting the next token. The word is basically token and word are similar in nature. You might hear token and word, being used interchangeably, but token is basically a part of the word. It can be part of the word or word itself, right? So LLMs predict next token, and that's where if you type anything on any chat GPT or asking a question, it will seem to you that's typing. It's a typewriter kind of stuff, right? But actually, what it's doing is predicting the next word. It's always predicting the next word, and therefore it's creating sentences, and that's very important to understand because we sometimes feel that we give something and it gives an output. Actually, it's just giving a next token with the highest probability, and basically the app chooses the word which has the highest probability and then pastes it and then puts back the same thing again and gets the next word and then puts back the same thing again, kind of stuff, right? While we're doing this, get into uh, further into this, right? Let's look at few of the LLMs, some of the apps which are based on some of the LLMs that are out in the market. I'll share my screen quickly. Uh, Let me see if you cannot see my screen, but fundamentally that there are three apps which basically it's important to understand that Chat GPT is an app, while GPT is an LLM, right? So Copilot is an app, but Copilot is based on again GPT-4. So it's an app. Chat GPT is an app, but both are based on GPT, which has come from OpenAI. And then Gemini is there. Basically, Gemini is another one which basically has come from Google, and they have their own LLM called Gemini. So Gemini is based on Gemini. Sorry, anyone has any question? Yeah, so they basically, if you talk to anyone, the three LLM based apps. One is Copilot from Microsoft. One is ChatGPT from OpenAI, and one is Gemini from Google Gemini. So that's basically the three main apps. Now, so some of the things that I talked about, right? Like let's say I want to ask uh, I want to ask Copilot to write a code, right? So I can say write a code. Let's say I want to say a Python code to add two numbers. A simple code, right? Not a very complicated code. So let's see if Copilot can write a very simple code for me. Right. So basically, it has written like a simple code that add number is a function which is just return add and then can print it, right? So it's a very simple code that it has written. But interestingly, it has written a code, right? Again, if you see, it was like seemingly as if it was typing, right? So everything here which has written like let's def add underscore numbers, right? After spitting out, after writing def, it actually is also it starts predicting the next word, right? So it's a add underscore numbers, and then it predicts the next one. That's basically the brackets a comma b that predicts adds. So basically it's just predicting, and that's very important. That's always predicting the next word, and therefore you feel like it's typing on it. You can actually take the same example and see how Gemini does it, right? How can Gemini, if I put on Gemini and say, can you write a Python code to add two numbers? The same thing that I'm asking Gemini to do. Let's see what Gemini does. Right, so Gemini has done something similar. Num1, num2, sum is equal to this, and print the sum, right? It's different if you look at it from here, a little bit different, but pretty much the code does the same thing, kind of stuff, right? So that's basically how LLM based app can do. I can also say, let's say generate a simple thing like generate an image of. Let's say I want to, I'm from Rajasthan, so I'll just say Rajasthan in 2050. I want to visualize, Rajasthan and what would Rajasthan look like in 2050, right? So let's see what what Copilot does, right? And we can do the same thing here, Gemini. Let's see what Gemini does. I'm not using ChatGPT because primarily ChatGPT and Copilot are based on the same LLM, so would expect them to do the same thing. So it's taking some time to generate, but it has generated some images here. It's interesting that it is showing palaces, some kind of palace with cars and flying, all kinds of stuff, right? So it has created something which is interesting. Uh, um, but it has taken the context that there are people with wearing saris and turbans and those kind of stuff, right? Let's see what Gemini has done, right? The Gemini has actually painted like some kind of palace with the wind turbine kind of stuff. So it is less futuristic in nature, but while a co-pilot was more futuristic, right? So it's interesting, that they can generate these kind of images and these are all images which are unique. It's not like you can find these images somewhere on the web. We can also, let's say, one of the things which also these apps do is maintain the context, right? So let's say I want to let's say I want to say what, who is, can you say I want to, can you tell me more about, let's say I want to ask about myself, right? Manoj Gupta of Plotch.ai, right? Can you tell me about Manoj Gupta Plotch.ai? Let's say what it spits out and stuff, right? So what it's basically, LLMs have a lot of this data which has they've been trained on, and they basically get trained on whatever is publicly available. So they would pull out, that data from variety of sources on the website on which they've been trained, and basically spit it out. And that's basically they've said that, foundency or Plotch.ai and all that stuff, right? Interesting thing. Let's say I ask him, can you, let's see, I'm just trying this. Can you tell me when he was born, right? I'm not saying Manoj was born. I'm asking, can you tell me when he was born? It can, let's see if he understands from this. At least it's Manoj Gupta. So it's basically completely incorrect. So I'm not born 1967, right? There's something, so there's something which is this, right? It's called hallucination, you know, that this app actually has now hallucinating. It's just creating something which actually is not true and factual, right? So one thing is that if you go to any of these apps, they will tell you very clearly that apps can be inaccurate. They can spit out data which is inaccurate. Because why? Because they're always predicting. They're not fetching from somewhere. It's a very different thing LLMs do. They're always predicting based on what they've been trained. There's no database where they're going and fetching kind of stuff, right? And that's why LLMs can be, inaccurate. They can hallucinate. So that's the one thing that, something that I just wanted to show you, right? The second thing, LLMs, and if you log in there, they will always tell you that don't put any private data, right? So if I put any data, right, let's say Manoj Gupta was born in this year. Can you tell me more about Manoj Gupta? That data actually is going into LLM. The data is getting, somewhere is getting trained, and next time someone can actually know my birth year, right? Which I may not want to, tell in public kind of stuff, right? So putting any sensitive data here in LLM, in these apps is, should be completely avoided kind of stuff, right? Even if you think, no, this is your account, this is something that, no one will know about. Anything you put here, someone else, because it's the LLM, which is, is a trained model, it can spit it out to someone else. And that something is something that you should, be careful about and stuff, right? So that's one thing. The third thing which basically LLM suffer from is bias, right? A lot of this data actually has come from in English text, and English text from variety of American websites and European websites and those kind of stuff, right? So they may have a lot of bias. They may not have the point of view of an Indian, for example, compared to an American kind of stuff, right? So they may favor certain kind of ethnic some kind of some certain kind of religion or some certain kind of country in their outputs, which can be can be because they're biased kind of stuff, right? Because they're biased on the data which has been fed to them, right? So hallucination is a problem in LLM. Bias is a problem in LLM, and privacy of data. So because these are public, you should be very careful about putting that data, right? So that's something, the three things that I want to point it out as we are doing kind of stuff, right? Any questions till now? We have talked about what LLMs can do. We talked about the apps, the three apps that I just showed based on some of the LLMs. We'll now get into LLMs, actually, what LLMs are. Uh, any questions till now from anyone? Okay, if you have any questions, feel free to ask me. Now, LLMs are modeled like a brain. That's basically how LLMs have been designed. And it's based on uh, one of the subset of research, which a research topic was a neural network. So neural networks is being studied for last 40, 50 years. And the idea was, can we replicate how a brain functions, right? So LLMs basically are model like a brain. That's basically is how it is, right? So we have a brain here, which is basically human brain, and then we're trying to create artificial intelligence, which is similar to a brain kind of stuff, right? Now, how a brain is like, a brain has trillions of neurons. Like this thing is a neuron. That's this yellow thing here is a neuron, right? And basically all these neurons, these trillions, 100 trillion of these neurons actually are connected to each other in our brain. And basically the connecting part is called synapse. And that basically one neuron and is basically is talking to another neuron, and there are trillions of these neurons which are talking to each other. Interestingly, and this is the interesting fact, that we don't store any facts. We basically learn from these facts. So while someone can say that I know this formula and this kind of stuff, we have actually learned it. It's not stored somewhere. And the classic example is that if you read a novel, right, you can actually summarize a novel, but you don't remember the exact words and those kind of stuff, right? So somewhere that novel has gone into your head, but basically you have learned from it and you can summarize kind of stuff, right? So that's the same thing which is happening in the neural networks, that nothing is getting stored. It's just that you learn. It's called deep learning method, right? You're learning from the data which has been fed to you, right? So basically it's similar to a neuron and those kind of stuff. There's mathematical models that have been created and which become part of the LLMs core, model functioning and algorithms. It's primarily, if you look at it, it is pretty much the same structure that comes out of, right? And this is how the neural networks are there. There's something which comes from the input side, which can be a query, your answer, your image, and what it comes out of the output is basically the next word or the next pixel which needs to be generated. Again, it goes back, and then again the next pixel or the next word comes out, and therefore how the picture is getting created and how the sentences are getting created is through based on this very complicated neural network, which basically is operating. It has input layer, hidden layers, and output layer, right? So multiple hidden layers. The more the hidden layers are, the more the deep the learning is, kind of stuff. And it has a lot of these weights and biases. So each of these nodes is connected to all the nodes, and each of these basically lines, which basically connects one node to another node, has a weight. And learning process is in LLM is to somehow come to that weight, that number, that numerical number, and therefore create a model, right? That's basically how the whole model works. LLM model works. It's a bit complicated. It's you know even if you, I think, doing a PhD, it's difficult to comprehend a lot of times what this actually is doing. But idea here is to give you a very high level overview and tell you that actually it's a very complex thing which is happening, but nowhere the facts and the data is getting stored. It's just that some kind of weights and numbers are getting stored, which eventually are creating an output. And that's a very interesting thing. Yeah. So again, it's a very complicated matrix multiplication, all these things which is happening. And an idea is to tell you that the complexity here is extremely high. When you come to the model part, while we're just typing and we're getting something out, it looks very easy, right? So LLM doesn't have a database, and that's something that uh, you know it's important for you to know. It has only weights and biases. So if you get hold of any open source LLM, you actually get a weights and bias, a data with you, which you load, and then you create some kind of application on top of it, kind of stuff, right? And there's no database. There's nowhere it's stored that Manoj Gupta is founder of Plotch.ai. Nowhere it's stored, right? That basically is the interesting part. And as I said, there are a lot of numerical values which LLMs, learn through training. Training is a very important part of an LLM, large language model, right? Uh, that's what LLM stands for. So it's large, means lot of the model is very large, and a lot of data on which it gets trained is also very, very large, right? And there, because it gets trained on so much of data, it actually can predict based on the training the closest word which it needs to predict for the sentences, right? Let's say, who is the founder of Plotch.ai? That's something that goes into the model, right? So what would the first word which will come out, right? So the first word will be Manoj, right? So it will predict Manoj. Okay, then it will go back, like, who is the founder of Plotch.ai? Manoj, and say, okay, it has to be Gupta, right? Because somewhere a lot of the training Manoj and Gupta has come a lot of times, right? Then go back again, who is the founder of Plotch.ai? Manoj Gupta is. So next word is kind of stuff. So that's how it builds the whole sentences and those kind of stuff, right? And LLMs come in different sizes, right? They're large, but they can have thousands parameters, million parameters, billions parameters, and trillions of parameters, right? And they're measured in parameters. So a lot of times when you look at, let's say, Llama is an LLM from Meta, which is Facebook, right? And they may say 7B, which means 7 billion parameters, is something that they have. There are the top LLMs which are there. We started with GPT-1. GPT-1 came in 2018. They had 175 million parameters. It is, of course, a closed LLM, which means it's not an open source. It's a closed. You don't have access to their weights and their source code kind of stuff, right? Then GPT-2 came. Then GPT-3 came, right? GPT-2 had 1.5 billion parameters. GPT-3 was 75 billion. All these have come from OpenAI, which is a company in US. Then GPT-4, which has come this year. GPT-4o is the next version. GPT-4o is where basically where it can take a lot of these image and text both and generate some kind of mixed mode output also. Right. Gemini is from Google. We don't know the size of it, how big it is. It's fairly large. Again, it's a closed, LLM model. Llama is from Meta. It comes in two variants, 7B, which is 7 billion parameters, and 70 billion parameters. But it's open source. You can actually take Llama, and a lot of people do that. They take Llama and they can fine tune that on that LLM and build their own LLMs kind of stuff, right? Which is custom to their data set. Mistral is from France, so it's something, a company which is getting a lot of attention. It has actually one which comes into SLM, which is small language model. It's basically the 7B. 7 billion is still very large number, but compared to the 75 trillion LLM parameters which GPT-4 has, Mistral has 7B, which is actually a very small compared to the LLMs which are there, but it's open source. So Llama and Mistral are open source. So you can actually take these LLMs and build your own LLMs if you want to build your own stuff. Any questions till now? Anyone? And as I said, LLMs need lot of training. They basically get fed. It's like a big elephant who gets fed a lot of food in it. This kind of stuff. So what you see when I'm typing on Chat GPT or Copilot or Gemini and asking question is basically is a pre-trained LLM. It's been trained so much, but it's already now it's pre-trained. It basically not getting trained. Um, but 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 before they present it to us, like they get trained a lot. A lot of data gets fed into them, right? And the training data is images, any product data. Sorry, I just basically it's your websites, your for proprietary data, it can be order data, customer data, kind of stuff, right? GPT-4 is trained on roughly 13 trillion tokens, right? Which means 10 trillion words. Right? That's like large number of data that's been trained on. The training cost itself was $100 million, and got trained for more than 6 months, 4 to 5, 4 to 6 months kind of stuff, right? And that's how the GPT-4 came. GPT-4 is people are saying is close to the human brain. Like GPT-1 was very small, GPT-2 and GPT-3 was still smaller, but GPT-4 is very coming very close to the human brain, and primarily because it's been trained so much. It's trained on almost the whole universe of data which exist, public data which exist, and stuff, right? And as I said, ChatGPT is an app. We should not confuse ChatGPT with GPT, because ChatGPT is an app built on GPT LLM. You can have any app being built on any of the LLMs, right? You can also build your own app on GPT using APIs, right? So that distinction is very important if if just to get a very good understanding of the lay of the land if you're looking at AI. Now, this is an interesting question that I have. How long it took top apps to hit 100 million monthly users, right? Google Translate took 78, months, which is more than 6 years. It took 6 years Google Translate to get to 100 million users, right? Uber took 70 months, again close to 6 years. Telegram was approximately 5 years. Spotify was less than 5 years. Pinterest took like close to, you can say, 40 months is approximately 5 months again. Instagram took 30, which again more than close to, you can say, 2.5 years, right? TikTok was 9 months, right? Within 9 months it reached to 100 million monthly users. Chat GPT, what do you think? How many months? Of course, months, because it is higher than TikTok. How many months that do you think Chat GPT took to get to 100 million monthly users? Anyone here? So basically, it took just 2 months for them to reach 100 million, you know, users, and that basically tells the kind of excitement there is in AI. Right, the whole universe was so excited about ChatGPT because the kind of output they were seeing out of it. Right, it just you know, even TikTok, which is so viral in nature, which took 9 months, ChatGPT just took 2 months to get to 100 million users. So that's basically the power of AI that we're looking at. The GPT-1 came in 2018, GPT-2 in 2019, 2020 GPT-3. Then 2 years after that, ChatGPT came, which is based on GPT-3. The application actually came. The GPTs were getting built. The application came, and then in 2023 GPT-4, and then this year GPT-4o has come. Right? So that's basically how the GPTs have come. And these are basically the size, the GPT-1, this is 100 million, GPT-2 was like 1.5, GPT-3 75 billion, and GPT-4 is 175 trillion, is 1,000 times more. Right? So that basically is the extent of change in the models and the size of the model which has come in last 3-4 years, and it's very defining moment in history for us if we look from AI perspective, because these kind of stuff will change our life in next decade and coming future. How we will do, what kind of job we will do, what kind of work we will do, how we'll interact in our life, what kind of tools that we use, kind of stuff. This is the kind of training, the data which actually has been fed into GPTs, right? GPT-1 4.0 4.8 GB of data was fed for training. GPT-2 about 40 GB, GPT-3 570 GB, and GPT-4 is more than a trillion bytes of data, right? So and that basically also increases the model size. The model is the size is based on the parameters, and the parameters are basically the weights that I talked about, the transformer weights, right? How many weights do you have? How many parameters that you have? And here basically to tell you that GPT-3 and GPT-4, the difference is that GPT-3 is text only, while GPT-4 and afterwards is text and image. And we just saw the example where image was, we used the image to basically actually we didn't see that example, but you can actually feed an image and say that, can you tell me a little bit about that image, or can you summarize the image, or can you identify the key objects in this image, kind of stuff. So actually you can give the image and they can tell you what kind of objects are there in that image. And this is to tell you that the GPT-4 is very close to human brain. Well, Palm to Llama and all these are very far. For GPT-4 is now getting very, very close to human. So pretty much you are looking at replicating what humans can do. Um, while there's intelligence part which is coming, a lot of people are also now talking about artificial emotional intelligence, which means that today if I'm saying something, can the machine detect that I'm angry or I'm sad, or am I happy, kind of stuff, right? If I tell a joke to the machine, will the machine laugh, for example, in a humorous way, kind of stuff, right? So artificial intelligence, artificial emotional intelligence also, which is emotion AI, is also a very hot topic right now, and a lot of people are working on it. Again, has a lot of benefits, a lot of tools which we can imagine you know um, to be built on emotion AI. This is a pretty much a classic LLM flow. You basically an app. It can be a chat GPT app. Basically, you put a query. Now the context, it can either be from your own database, vector database, or those kind of stuff. So context may be there, or context may not be there. But this query goes as a prompt, and you might have heard of prompt in AI, that prompt engineering. How do you design a good prompt and those kind of stuff. So basically, this virtually is a combination of query and context. kind of stuff. Then prompt goes into an LM, which is being trained on a lot of data. Like there's a training part here, and then it gives a response. So this part is called inferencing part. So you might, if you're working in AI, someone will say, how good your model is in inferencing, how fast it can inference. So inference is primarily the response part. And the training part is how much it will cost me to train, how much time it will take train, what is the, for example, my training data set and those kinds of stuff. So that basically is part of training. So the LLM gets trained, and then they become ready for inferencing. Right? So these are the terminology you might hear if you're working in AI or talking about AI kind of stuff. And there are other things like embedding models, everything, which we'll talk about in later webinars as we go deeper. Right. Another interesting thing which is happening from an infrastructure perspective is that CPU versus GPU. CPU is your computational, processing units, and GPU is your graphical processing units. GPUs came into being about 20 years back, primarily for gaming consoles and those kind of stuff. But they have taken a completely different, uh, I would say from a demand perspective, there's so much high demand for GPUs these days because a lot of AI actually gets trained on GPU using GPUs, right? So any company which is building GPUs is getting valued a lot. And there's a company called Nvidia, basically, which actually just right now, just the share price is going out of the roof. And this is again a terminology that you will hear, that my LLM is CPU friendly. My LLM actually runs on GPU only, this type of GPU and those kind of stuff, right? I need these many GPUs. There's so much demand that GPUs actually are not available these days. So if you go and say, I want, 100 GPUs from any of the cloud providers, they probably will not be able to give it to you. So because there's so much of demand for GPUs. And there's this show that this company called Nvidia, and this interesting thing which is happening is that the share price has gone from like $500 to like $1,100 just in like 5 months because of AI. It's complete because of AI, because they make GPUs and so much of demand for GPUs that the share price is just going out of the roof. More than 100% jump in last 6 months alone in US. Uh, and a lot of AI cases, use cases in ONDC, and we'll talk about that in our future webinars. But pretty much that's the stuff that I had for this webinar. Any questions from anyone? I know a lot of stuff that you might have heard for the first time. There are a lot of stuff you basically may not have understood, which is fine. But the idea was to give a very high level overview of what AI, LLM is in AI, and maybe prepare you for your next reading or next webinar or next project, so that when you're presented an LLM, you are fairly familiar that okay, these are terminologies kind of stuff, right? Yeah, any questions from anyone?
Hi, Manoj.
Hi, yeah.
Manoj, this is Chaitanya from IDFC First Bank.
Hi, Chaitanya. Yes.
Thanks so much for taking time out and trying to educate all of us. I believe, at least for me, this is really totally new. But where I am curious, and my question is, for someone from my industry, banking industry,
Yeah.
where is this AI, applicable? And if you can give us some ideas. Most of our banking data is private, and on a small set of data with available with only one bank, how much can a model be trained, and what will be the use cases for such kind of model? If you can give some ideas, that would be.
No, no, valid question, Chaitanya, and thanks for attending the webinar. So basically, it doesn't matter what kind of data set you have, right? You can have a very small data set, you can have a large data set, right? The kind of LLMs that we know, GPTs and Gemini, they basically are based on public data sets. So basically, they take data from all the websites, they scrape the website, they have a lot of books They feed that, a lot of books. They take content from books and they feed a lot of blogs. They feed. All these are public in nature, right? But a bank, as you rightly said, private data, and they may have applications, of this LLM, but they want to do that on private data only. Now, for that, the two ways people do that, one is that you can either fine tune the open source LLM, which are there like Llama, and basically use that for your own data set, and use that in your own domain, so that, because it's not public, basically all the data which is you're getting trained on, that LLM is yours, the data set is yours, it's getting used in the context in which basically, it should be used, right? Now, but there the caveats there. For example, you have built, IDFC has built an LLM for their customers. Customer A, Manoj Gupta, should not be able to see bank balance of, you know, let's say Chaitanya, for example, kind of stuff,
Yeah.
right? Or vice versa. So that basically is something that the bank needs to take care that, it should not happen, that happens, kind of stuff, right? The one of the first use cases for bank is fraud detection. So that basically
Good.
is something that, as a bank, you can feed the data, which can be more like a PII data, but you detect the patterns, you detect whether there's a fraud happening, kind of stuff, right? And those things, are one of the first use cases the banks are taking is for those. Of course, the generic side is the chatbots and the stuff where you can do generic customer care. For example, it can be, how do I open a bank account? So that's a generic, public knowledge kind of stuff. So you can create an LLM just for that. You can create an internal LLM for just for your own analytics. So LLMs are good in giving you derived data, some kind of insights that, w- what happened in this branch, with respect to number of accounts, kind of stuff, right? So someone can query and get the data. Okay, in let's say in Kandivali branch in Mumbai, 100 accounts opened, but 50 got closed, kind of stuff, right?
Mm.
Something like that, you can create internal LLMs, kind of stuff.
Good.
So there's a lot of application. Of course, the fraud detection has the highest ROI with respect to unusual activity, kind of stuff. That's how, again, you can detect.
Thanks. Thanks so much.
Any other question from anyone? Okay, I think we'll wrap up here then. Thank you, and hopefully you like the webinar, and we'll keep you updated on the next webinar, which is coming in AI as part of our AI series. Thank you. Have a great weekend. Good night. Bye bye.